Okay, welcome back. We're on horizontal shifting of sine graph. It's possible you might be given a graph of a sine function and you're asked to find the function, the exact function. So the function will be within these four graphs. So the parent graph is the blue one. So this is a sine graph because it starts from the origin. Y cosine starts from the y-axis, that's the intercept, y-intercept. So this is y equal to a sine kx. So we can get the other three by shifting this blue graph either left or right. And also reflect it about the x-axis. So look at this, y. This one in blue. Look at the red one. So if here is a, because here a, the absolute a, is called the amplitude. So if here is a, here is minus a. So this graph, the graph of the red function, so this one will be y equal to, as you can see, it is now y equal to minus a sine kx. So do you see it? If you multiply by minus, you get the red graph. Again, we've gotten the two, this blue and red, remaining the other one. So if I decide to shift the blue graph to b units, so this graph, the equation will be y equals a sine k bracket x minus b. Yes. So, but if I shift it to the left, b unit, that's here is now minus b. This graph, this one will be y equal to a sine k bracket x plus b. So, and again, there's what we call the period. The period is the distance or the time, that's from here. So you notice that this graph started from this and ends here. So it will still continue. So this is the end point. This is called one period. So from here to here is called a period. And it will represent it by, that is denoted by t. And one period, t, is always 2 pi over k. And remember, k, where k must be a number greater than 0. K must be a positive number. Or if it's a negative number, we use a property. That's odd function property, that's sine negative k is now minus sine k. So we use that property. And also, since this is the one complete period is 2 pi over k. So I'm saying that here is 2 pi over k. Why this one? Remember, we shifted this one b unit to the right. So the point here will be 2 pi over k plus b. So that will be the one that it will end here. It started from b and it will end here. Why this one that shifted to the left will be 2 pi over k minus b. So that's it. So let's look at this question. Okay, we are given this and we're asked to find the graph that is given. So this question requires two theorem or formulas. First of all, because looking at this is a sine graph. As you can see from what I just explained, you see that assuming this started from the origin, do you see it? Assuming we started from the origin, it will go like this. Do you see? So meaning that the answer A, remember I told you the graph of, from what I said, the graph of sine is always y equal to minus A sine k x minus b. So if it is downward, it is minus A. But if it's up, it's plus A from what I just explained. So the graph of this must be minus A sine. And from here, you see that our A, as you can see, our minus A is 2. So we have minus 2 sine. So remaining K. And how do you get K? We get it using our period. So what was the period? As you can see, this graph started from here and it will end here before repeating. Or it will start from here and end here before repeating. So what do you notice? Here is also the period. One period. Or we'll say from here to here is one period. And as I've said, period T is always, I say that T is always 2 pi over K. Yes. And from here, how do you get from here? What's the distance from 0 to pi? So this is pi. Yes, period here is pi. Or if I do 2 pi minus pi, pi. So what do you have to say? Our K is 2. So our K is 2. X minus. Shifting to the right is minus. Shifting to the left is plus. So that's why I have minus. And how many did we shift? Pi over, we shifted pi over 12 units. As you can see. Assuming it were to be the original graph, it will start from 0. Or it started from pi over 12. So that's the shift from here to here. That's the phase angle, which is pi over 12. So which of the option? Okay, there is nothing like that. Meaning that we need to employ second formula. So let's open up this first. We have minus 2 sine 2x minus pi over 6. So let's check the option to know which one gives us minus 2 sine. And how do you check it? We use what we call addition formula for sine. So there is one formula, addition formula, that says that sine A plus or minus B is always sine A cos B. So okay, I have minus. We'll use minus cos A sine B. So that's the formula we're going to use. The addition formula for sine A plus or minus B is that. So we'll check sine 2x, we are using minus pi over 6. So this is now sine A is 2x and B is pi over 6. We have minus here, so we use minus. So plus for plus, minus for minus. Cos 2x sine pi over 6. So let's check the value. From here, sine 2 cos pi over 6, which is cos 30. Cos 30 is, that is sine 2x times cos 30 is root 3 over 2 minus cos 2x. Sine 30 is half. So you see that this is equal to root 3 over 2 sine 2x minus half cos 2x. So plugging it back to this, so we have that sine 2x minus pi over 6 is equal to root 3 over 2 sine 2x minus half cos 2x. So factor. If we factor half, I have root 3 sine 2x minus cos 2x. So finally, remember, our main aim is to check if any of them is this. I have minus 2 sine that, so therefore minus 2 sine 2x minus pi over 6 will be equal to minus 2 times half, because we've gotten this as this. So which is this. So we have minus root 3 sine 2x plus cos 2x. So which of them is the answer? So that's the function. Y is equal to, maybe let's write cos 2x minus root 3 sine 2x. Let's check which one is the answer. On A.